Hello and welcome back. Today on the bench got something a bit different. This is a Howell TSC2000 and it's quite an amazing bit of kit. Very well built, lovely construction, nearly on a par with some of the HP stuff. I presume it's 1980s, early 90s maybe. I've had it for a while, tried to get it going a few times and not really getting anywhere because I've got no schematics or nothing. I did manage to find a manual of sorts for a TSC2000 which is similar to this. I gave this and the manual to somebody to try and fix for me. That never happened and I never got the manual back, unfortunately. It's a fucking nuisance, to be honest, but never mind. I mean, it took me ages to find the manual. Anyway, getting on. What does it do? As far as I know, this thing was something to do with the tapes that, you know, like if you look at any sort of 1960s space age sort of film, they've got big computers in the background with tapes going round and round, which I presume was some sort of memory or random memory or something like that, not being a computer wizard. And I think these were something to do with either calibrating those or testing those or something like that. So what it should do, I think, is put a square wave out and a sine wave out. That bit doesn't work, and obviously here we've got like a range of 100 Hz to 10 megahertz. Obviously you can set a square level and a frequency. And then I think also what there is here is a precision DC output, hence the calibrator, which can be set, I think, all the way to 9.9, hold on, what can it? Right, all the way to 19.999 volts. That used to work, no longer does. Also, I think what it does, again I'm sort of speculating here because I've got no manual, is that it's got a digital voltmeter, which I think is this part. So obviously that's to test DC volts, AC volts, kiloohms, but then we've got kiloohms high voltage and kiloohms low voltage. What does that mean? I'm not sure. And then we've got DC milliamps and AC milliamps, which I presume are these test terminals here. The Cal, I don't know, I'm not getting anything really out of there. And then we've got, I think, a THD meter, which is this, where we can check the second and third harmonic content of a signal. This sort of works, and I think here we've got a signal to noise ratio, we can test that. Not quite sure there. Monitor, maybe that's to monitor this section here, or we can test an input maybe. Analyze, I don't know. So maybe it's got some sort of, well, I don't know, analyzer, I don't know. And then we've got this meter range, obviously, millivolts, 100 millivolts, 1 volt or percent, or 1% I presume, 10 volts or 10% I presume, or dB. Also got a sine level here and a relative, which is got a cal position like on scopes. So let's have a look at a bit of the construction. Okay, we've got 1, 2, 3, 4, 5, 6, 7 cards coming off a big main motherboard. This here I think is the power supply, and as you can see these beasties here are reed relays. It's got quite a few of those in, and as you can also see there's quite a few tantalum caps in here, as well as preset potentiometers. As I said, it looks to be very well made with good components. These are Spragues, I think. Pretty damn sure they're Spragues. Right, let's have a look at the cards. Now then, when I got it, I think it sort of worked, and there was a tantalum cap here that had basically blown up. It had like aluminium sort of like type material spewing out of it. I've tried to fix this a few times. I've no idea how though, or what is going on. We've got a few ICs on here. We've got a transistor array, which is just basically all transistors. I remember there's one. Hold on. I think there's 1, 2, 3, 4. There's maybe 5 or 6 transistors in there, all on the same substrate. There's a few logic ICs here, NAND and NOR gates, I think. We've got an MLM 324, which I think is a quad op amp, and we've got another dual op amp here. As you can see, I've taken most of the tantalums off here and just replaced them with electrolytics. I mean, it shouldn't affect the operation too much, as all the caps are doing, the tantalum caps were doing, as far as I know, was providing decoupling. There's a few precision resistors, so obviously they must set something precisely. Adjustable cap, some adjustable presets, and some test points up here, which I have tested, and I just get varying DC voltages off them, nothing signal wise. As you can see, it's nice, nice construction. This is interesting here. It's been posited that this could be some sort of 20 filter type thing, but we don't know. It's two-side construction. So this first one here is the main oscillator board, and as far as I can make out, we're getting nothing off it. Just put him in there. Next is an AC, oh no, sorry, not an AC, a leveling filter, which maybe this is doing some sort of nulling function to null out the fundamental, if we was to be testing total harmonic distortion, second or third harmonic type thing, or something of that nature. Again, we've got a lot of tantalums, the same type of reed relays. I've tried to find information on them, can't. Electronic applications with like a sort of atomic, like a, what do you call it, atom, and what are them things that go on the outside, electrons and neutrons or whatever. You can see I'm showing my ignorance again. Got some logic. Oh, I'm not quite sure if that NM3900 is a operational the OTAs. Is it OTA? I don't know. Not sure anyway. A few other ICs. Again, without a schematic, we're in the dark really. All I've done is I've tried to go through and test every sort of transistor and component and what have you, and There we go. Let's snap that bit up. Of course, obviously, every time you handle something like this, you just, got a good chance of knackering it. The third one is the analyser. The third board is the analyser. This is a revision B board. The other two are revision A's. Again, similar construction. More logic. More logic. Why some are on a what do you call it, IC holder thingy, and some on, I do not know. Got some very big what are they? I think they're film caps, aren't they? Very big film caps. I've not seen any as big as those. We've got some different relays on here, reed relays. They look to be similar in, mind you, they look to be, I think the other one's a single pole single throw. I think this is a double pole single throw as these ones. Again, loads of tantalums. I've been through and tested those with an ESR meter and with an ohm meter on diode check, just to see if they're shorted. Obviously that one there must be providing some sort of what do you call it, decoupling sort of function. There's a few electrolytics, again in the dark. Number 4, again same construction, and this one is, I'm trying not to touch the back in case of electrostatic, beat frequency oscillator synthesizer. A lot more logic on this one, here and here and here, with some other gubbins going here. We've got another LM3900N, and apart from that, again we're in the dark. Different tantalums, more reed relays. To do this one-handed. Now this one is a frequency meter, so it has got a frequency counter. So this one looks, we've basically got a crystal, more logic, a big IC which is a Mostec MK5002N, Malaysia. So obviously that's doing some sort of frequency counting function. Another one with a ribbon on it. Digital DVM. Now you would have thought there would have been a sort of a big chip on here, a custom ASIC or something like that, but no, all looks to be sort of logic. Try and get you in a bit close, see if you can ID some of the some of those ICs, IDing ICs. And finally we have an analog DVM. So what did that one was digital, was it? Yeah, that's digital and this is analog. When I come to power this up the other day, there was smoke pouring out of it, and it took me a while to find it before it burnt out a resistor. So we don't know what that resistor was down there, but it seems to be a lot of 150 ohms, so that's what I've just popped in there, as well as replacing the tantalum, which it turned out to be, was the thing that was smoking, with a electrolytic. This one seems to be a lot more simple. We've got another, is that an LM3900? No, that's an LM496. A lot more transistors, Most of the transistors in this seems to be 2N3904s. And we've got a lot of presets here with a very sort of weird, not seen that before. It's obviously a 1% 1K resistor going right over the top of an IC, which is a CA3046, which is another transistor array. Right, that's it for the cards. Let's go and have a look at the rest of it. Right, looking underneath, as you can see, there's a lot of buses underneath there. They're basically just buses linking all the individual cards and linking the power supply with that. This board is interesting and of note, which I think this is the precision DC voltage source. There's a lot of what look like to be these are plus minus 0.1% resistors, so they must be setting the various voltages out. I mean, we could confirm that by seeing whether this here is linked to it. What wires we got there? Yeah, it's got to be, that's got to be linked with that, this switch here. Some nice old Phillips caps, and that's it. There's another board here which I think is the display drivers, probably for this meter, is it a meter? Display here, and that's about all she wrote. Alright, let's power it up. I'm just having a quick test of the DC output thing, the DC source. We've got 8.6 dialed in, and we're only getting 1.4. When I click the most significant digit on, we get a fault reading and we get 3.1 volts, so obviously that's wrong. I might actually be able to fault find that board. I mean, it's just a bloody power supply, isn't it, really? What else have we got? Let's use the HP doo-doo whatnot and connect up to the sine out. Every time I have done so, I mean, it's not bloody work, but you never know. Okay. Oh, it's not liking that. Error 31. Error code 31, cannot make measurement. Let's try that again. Oops. No, well, there's obviously must be something coming out of that then. We'll try that again in a minute. Right, so there we've got 1 kilohertz 1 volt going in. Make sure we've got that all feed the signal from the HB8903B back into the thing, yeah. So the HB blah blah whatever, 1 kilohertz at 0.9. It was reading roughly on the other day. Not now. Input 80 volts, 3.1. Okay. Now then, the second harmonic yeah, that's not really a stable reading, is it? The HB8903B is 0.0. Hang on. yeah, 0.002. Maybe that's why I can't read it. Maybe we need something with a bit more distortion. Signal to noise ratio. Low. Kilohertz thing isn't working. Right, and it seems to, it just jumps around then. dB volts. Just reading plus 112.3 dBV. Let's try and knock in the amplitude down. Amplitude 0.1. No change. Right, hold on. See if that. No, it makes no difference. Sine level. No, that's not really. Let's try signal to noise. Right, we don't know whether that sine level is controlling this. We don't know. AC volts, it's got no reading on the meter. The ohm meter seems to work, but it reads wrong. And they've got this here, which I would presume is a range for the ohm meter resistance. And then again, you see, it's got this 500 volts AC. Does that mean you can read the impedance of something? We don't know. Let's see if there is a sine wave coming out. Remember that. Yeah, so it's a shame this isn't working really. Input. It seems to work, and then other days doesn't work, various things. The frequency meter was working the other day, obviously isn't now. So there we go, just a quick look at that. That's settled down now. It's a real shame, because like I say, it's a really well made bit of kit. You know, you can stick it on your bench, you've got a nice, I mean, you've got a, I don't know what sort of current it can pop out. I mean, maybe, you know, the DC sort of power supply of it isn't that powerful, but it might be alright for powering the odd sort of thing, or calibrating voltmeters. But a pop with no manual, we're buggered. So all it is really is another piece of kit taking up space. I mean, you might as well just chuck the bloody thing, but it's really nicely made. I mean, you take it apart for all the bits like, but it does seem a shame, doesn't it? So I'm hoping that if I put this online, somebody out there has got a manual for it. If you have, can you get in touch please? It'd be really nice to get this going again. It's a nice bit of vintage kit. One last thought on this. From the little bit of research that I did, Bell and Howell, the people who used to make all the projectors, obviously made this. It looks like it was made in the UK. I've seen, like I say, I've seen similar sort of construction on HP gear, where I have seen very, very similar sort of construction. It's on the old Dynaco voltmeter. Maybe they made it for Bell and Howell, I don't know. You can also get these, exactly the same thing, a TSC2000 with a bit different colour scheme, made by a company called Data Tape. You see them, if you go and look online for them, you see them for sale in the States for silly money really, $300 odd or whatever. Why would you want $300 for something like this? I mean, unless it's calibrated, it's worth sod all, is it really? So anyway, something a bit different, no resolution, no fault finding or what have you, but thought we'd have a look at it anyway. Thank you all for watching, take care of yourselves and ta-ra for now.